Welcome, class. Today you're going to learn about something called Pythagorean triples. So go ahead and do this warm-up assignment. So press pause and then play when you're done, and we'll discuss what you noticed. Okay, so you used Pythagorean theorem to find the third side. And you should have noticed something special about all of these answers. So when you used Pythagorean theorem here, you should have gotten 5 for the third side because 3 squared plus 4 squared. So you have 9 plus 16 is 25. Take the square root, you get 5. The next one should have been 10, and then 15, and then 40. And for this last one, remember you're solving for a leg. So 30 squared plus b squared equals 50 squared. So then you get 2,500 equals b squared plus 900. Subtract the 900, 1,600, and then take the square root of both sides, b equals 40. So what did you notice? Well, one thing you should have noticed is all the answers were whole numbers or integers. And based on all the work we've been doing lately, most of the time your answers are irrational numbers when you have right triangles. But there are some cases where they will always be integer sides, and those are called Pythagorean triples. And then there's something else that you might notice. They're all multiples of this base case of 3, 4, 5, right? 6, 8, 10 is 3 times 2, 4 times 2, 5 times 2. And then 9 is 3 times 3, 4 times 3, 5 times 3, and then this is times 10, right? So this is 3, 4, 5 will be what we call a primitive, and then the rest will be what we call multiples, but they're all examples of Pythagorean triples. Okay, let's look at another example. So go ahead and find the third side of this triangle. So 5 squared plus 12 squared equals c squared. So that's 169 equals c squared. Take the square root of both sides, and you get 13. And then let's look. Do the same down here, but you'll also notice 5 times 2 is 10, 12 times 2 is 24, so we could make a conjecture that this third side might be 26. Go ahead and solve the Pythagorean theorem. You will see, yes, indeed, it is 26. So 5, 12, 13 is what we call a primitive. And then this will be a multiple. So open to your vocab list. You're going to add in Pythagorean triple, which is a right triangle whose sides are all whole numbers or integers. So 3, 4, 5, 6, 8, 10, those were triples. 5, 12, 13. And then a primitive is a type of triple whose sides do not have a common factor. Whoops. I don't know where to put this. Here. Do not have a common factor. So we have 3, 4, 5, 5, 12, 13, and then there's going to be 2 more that we're going to add shortly. All right, so here are the other 2. Go ahead, use your Pythagorean theorem to find the third side. So this one you'll set up 7 squared plus b squared equals 25 squared. Do out your Pythagorean theorem by subtracting 7 squared to both sides. You should get 24. And then this one, you should get 8. So you get 8. Because 8 squared plus 15 squared equals 17 squared. You'll notice with all of these, we do not know the angle measures. So if you're told that an angle is 30 degrees or 60 degrees, you will not be using the triples to find the missing side, okay? This is reserved if we do not know the angle measures. When we get to the trig unit, you will find a way to find the missing angles. So add this to your vocab list, memorized triples. Now, since we're doing distance learning, these will be open notes assessments. Typically, you will have these memorized, but you can have these on like a little cheat sheet on all of your assessments. So this would typically be in a non-calculator test. Same with the 30-60 90s and the 45-45 90 special right triangles. Okay, so let's go ahead and practice and look at when you would use this. So here we have missing sides of right triangles. You could always use Pythagorean theorem as a method. You may not use the special 30-60 90 and 45-45 90 shortcuts because we don't know the angles here. So just because it looks like a 30-60 90 does not make it a 30-60 90. So here, if you have your your primitives memorized, which I'll write here on the side, that becomes a shortcut. And this becomes very useful when you take pre-calculus and trigonometry. So this is really setting you up for a later course. But it could also help you solve word problems quicker, which we will see. Okay, so let's look at number 1. So 21 and 28, those are not in the memorized primitives list. Oh, by the way, there's infinite Pythagorean primitives, but these are the only ones you will be tested on. So here, yes, you could use Pythagorean theorem, but let's see, this must be a multiple of one of the primitives. So do you see a common factor, the greatest common factor between 21 and 28? Yeah, 7. So let's divide both of these by 7. So 7 times 3 is 21. 28 divided by 7 is 4. So that means it reduces down to 3, 4. So what's the missing side? 5. So this will be 5 times 7, right? Because these are all scaled up by 7. 5 times 7 is 35 centimeters. Okay, so it's a quicker way than using Pythagorean theorem. And when we get to similar triangles, you'll understand why this multiple system works. So number 2. So 16 and 20, that's not in our memorized list. So maybe it's a multiple. Well, let's see. They're both even. Actually, they're both divisible by 4. So divide them both by 4. There's a 5. 4. Oh, so it'll be a 3. So it's a 3, 4, 5. And you'll notice the 5 has to be the hypotenuse. So double check that because you might have a 4 and a 5, but if the 4 and the 5 are legs, the hypotenuse would not be 3. So then you'd have to use Pythagorean theorem. Okay, so then 3 times 4 is 12 miles. And that's it. And you can always check with Pythagorean theorem. Okay, 30 and 50. Oh, they're multiples of 10. So divide by 10. 3, 5. 5 is the hypotenuse, so 4 is the missing side. 40 feet. And then number 4, let's see. I'm seeing a divisible by 4. Also divisible by 8. So let's go with the greater factor. So divided by 8 is 5. Divided by 8 is 4. Oh, 3, 4, 5. So 3 times 8 is 24. Make sure you remember to multiply by that scale factor. And then 5, let's see. Oh, those are even. So divide by 2, 12, 13. So what's the missing side? Oh, 5. Oh, scale factor, 5 times 2, 10 inches. Again, you can check with Pythagorean theorem, and it will work. And then number 6, no common factor. It must be a primitive. Yes, it is. So that would be 7 feet. Because it's a primitive. Okay? So you start to recognize these patterns. Same thing with the 30, 60, 90, and 45, 45, 90. Go ahead, pause the video, try 7 through 12, and then hit play when you're ready. All right, so let's see. So number 7, is divisible by 5. So divide by 5, you get 5. Divide by 5 is 3, so then 4. 4 times 5 is 20 miles. Number 8, divide by, 3. So 5, 3. So what's the missing side? Good, 4. 4 times 3 is 12 centimeters. Number 9, what's the greatest common factor? There's a 3, there's a 2. Oh, therefore there's a 6. Looks like 6. So divide by 6. 30 divided by 6 is 5. 18 divided by 6 is 3. So it's a 3, 4, 5. 4 times 6 is 24 centimeters. Number 10, let's see. Divide by 2. 4, 5. Oh, it's a 3, 4, 5. The scale factor is 2. 3 times 2 is 6 meters. 11, no common factor. Check your list of primitives, and you will see it is 15 meters. And then 12, no common factor, 5 meters. 5, 12, 13. All right, go ahead, pause again, and we will reconvene when you are ready. All right, so number 13, common factor of 3. So divided by 3 is 5. 39 divided by 3 is 13. 13 is the hypotenuse, so 12. But remember the scale factor was 3, 36. Inches. 14, let's see, divided by 2. Let's start with divide by 2. So you get 8. 34 divided by 2 is 17. Check your primitive list. 15. 15 times 2 is 30 kilometers. 15, I think 9 will work. Divide by 9, 3, 5, 4 centimeters. Oops, but we have to multiply by the 9, 36. 16, even, so divide by 2. So you have 25, 7, check your list, 7, 24, 25, and then multiply by 2, 48 inches. And then the last one is the primitive, 3, 4, 5. And that's it. So as always, if you have any questions, please email or come to the extra help session. And do your assignment on Google Classroom. Have a great day.